Should be number 13, no calculator, from the 2017 AP test. Two particles move along the x-axis, 0 to 8. The x position is given by this thing, yuck, natural log, but derivative of natural log is 1 over times chain rule, so okay. Velocity of particle q is a polynomial, so that's nice for taking derivatives and antiderivatives. Particle q is at x equals 5 when t equals 0. Okay, I've got to be super careful here because this time, not only do I have two separate particles, p and q.
One's got velocity, one's got...
Yeah, one of them they gave me the position, one of them they gave me the velocity. And I mean, I don't even have to read. I'm sure I'm going to be taking derivatives and integrals of different pieces. So let's see what happens here. For 0 to 8, when is particle p moving to the left? Well, it doesn't say justify, but I kind of have to justify in my head to know what to do here. Moving to the left, what does that mean? Velocity is negative. So I want to know when v of p is negative. Velocity of p is negative. Well, so I need to get velocity of p. That would be dx dt. So 1 over the argument times the derivative of the argument and let's see, the topple factor. So something's going on at t equals 1. The bottom, 5 times 2, 10 times 1, bottom won't factor, so kind of stuck with that one. Okay, well, it's v equals 0 at t equals 1. And I'm only concerned about 0 to 8. So I'm going to test 0.5 maybe, and then 2, or 3, or 4, or 5, or 6, or 7, or 8. If I test 0.5, the top becomes, well, maybe this one would be easier, be negative 1 over, I'm only concerned about positives and negatives here, 0.5 minus 1 plus 10, definitely positive. So we're negative from 0 to 1. I am concerned where the bottom is 0. So I think I've got to find where the bottom is 0. How am I going to do that? Set it equal to 0, okay. And then how will I solve that quadratic? It'd be nice if I could factor.
Oh, you can't factor, yuck.
X equals negative b plus or minus the square root.
The quadratic.
B squared minus
4ac.
4ac all over 2a. Oh, this is good. I'm actually okay with this because I get 2 plus or minus square root of negative 36. So that's imaginary. The bottom is never 0. So I had to check it, but it worked out just fine. So 1 is the only 0 I'm worried about. Now let's find v of 2. So that would be, back up to this one, 2 over, I'll plug in 2. 2 squared is 4, minus 4 is 0, plus 10 is positive. So there's my sort of answer choices. So moving to the left on 0 to 1. Again, you're not really supposed to box your answer, but if it gets crowded like that,
And you are pretty confident.
and you're confident, go ahead and do it.
Why did he use a quadratic formula?
Because I needed to know when the bottom was 0. Because if the bottom changes from negative to positive, that's going to mess up me figuring out when this thing is positive and negative.
Okay.
But it didn't have any zeros. It turns out it's always positive, so that was good news. I didn't really have to worry about the bottom. It also means if you didn't worry about the bottom to begin with, you still would have got the problem right. Part B. 0 to 8, find all times during which the two particles travel in the same direction. Travel in the same direction. What's that mean? Same sign for what? Velocity, same sign. Okay. Well, I already know where P is moving to the left on 0 to 1. So basically it's asking me to do kind of the same thing for Q. From 0 to 8. But Q is, I already have V, and it's factorable, so that was nice of them. So at 3 and 5, something's going on. If I plug in 0, I get positive. If I plug in 4, I get negative times positive. And if I plug in 6 or 7 or 8, I get positive, which matches the alternating sign thing there. It might be helpful to put, because I'm looking where they have the same sign. So P is negative 0 to 1, and then positive thereafter. I don't know, it helps my brain to see the overlap if I put it the whole way down there. So between 1 and 3, they're both positive. And then from 5 to 8, they're both positive.
Are we allowed to have highlighters in the testing room?
I don't know the answer to that.
Probably not, huh?
I will ask. Part C. Find the acceleration of particle Q. So that would be dv dt of Q at time 2. Is the speed increasing, decreasing, or neither? Okay, well I can answer that as soon as I know the acceleration. So Q, oh, this is an easy one. Like if you know what you're doing, the derivative of V is 2t minus 8. If I plug in 2, I get negative 4. Okay, this is a multi-part question here. Find the acceleration. Did that. And it's labeled. The acceleration of Q is negative 4. Follow my equal signs. Negative 4.
And your evaluation lines.
Is the speed increasing, decreasing, or neither?
Okay, so the velocity and
Yeah, that's exactly what you're looking at. The velocity of Q
is negative.
at 2 is positive.
Oh. There's a river flood warning now.
And the acceleration of Q at 2 is negative.
Let's slow it down.
Therefore, Q is slowing down. Oh, I guess we should answer it how it asks. Speed is decreasing.
And they don't care about parameters.
Find the position of particle Q the first time it changes direction. Okay, changes direction. What does that mean in terms of our variables?
Velocity changes sign.
What'd you say?
Velocity changes sign.
Yeah, so changes direction would mean velocity changes sign. So from positive to negative or negative to positive. Wait, we've sort of already answered that question. Velocity of q is up here. We made a picture for this. Velocity changes sign at t equals 3. And t equals 5, but it said the first time. So I need the position of q at time equals 3. And all I have is the velocity of q. So how do I get from velocity to position? That would be an integral, antiderivative. So when antiderivative the velocity, that will get me something about the position. But I need some limits here.
The first time it changes direction.
So I definitely want to use 3. And it told me x of 0.
So let's just use this.
So let's use 0 and 3. Because I know what the position is at 0. In fact, I'm going to move that over. So 5 plus the antiderivative from 0 to 3, t squared minus 8t plus 15. I sense a safe stop in our near future here. I was about to grab the calculator and let the calculator do the work, but
This is without calculator.
this is no calculator.
Is this a safe stop here?
That is not a safe stop, because that is still calculus left to go, right?
Blech.
You've still got to integrate. So t cubed over 3 minus 4t squared plus 15t from 0 to 3. Is that a safe stop?
Yes. No. It's not calculator.
It's not calculator ready. It's a good way to say it. I can't put that in my calculator like that. Another way to say it is that's still calculus. Like last year you would not have known what that means.
We would have been like, heh.
So let's plug in 3. Almost there. I don't want to mess up any plug-in things, so I'm just going to plug 3 in. Officially, I should put in the minus zeros, but it's all going to be 0, so I'm going to just stop there and say that's... I guess I should label that.
Boxing it?
Yeah, it kind of draws their attention to it. That is x of q at time 3. I guess it would be okay if I didn't have it labeled because it's the only answer there, but it would be wise to label things. Questions on number 13? Again, take a glance at the time there. We're at 13 minutes. And
So that's equal to-
again, that's fine because I took plenty of time to answer questions and slow down and graph things. And so now you got a couple minutes left to check over it, make sure you did everything right. Anything on 13?